Ladies and gentlemen, good morning. And thanks, John, introducing me. And I would say that notwithstanding the climate changes in the world, the British weather always the same. Okay. Okay. I have a tight timing, so I will go through quickly through slides. Then later we can go back any slides you want for going deeper in details. Okay. So briefly, Transfluid, it's a company born in 1957, so next year we celebrate 60 years anniversary, and we're located north of Italy, very close to the Swiss border, close to Malpensa International Airport, and we employ more than 100 people worldwide. We have 7 subsidiaries around the world and more than 40 distributors. All of them, they are authorized service centers either, not only sales and spares. And MIT is one, I would say, one of the most important. And since, I guess, more than 30 years, we are cooperating with MIT. So today, we export outside the Italian border more than 85% of our production. Our production is completely 100% made in Italy. And we produce a wide variety of transmissions devices such as constant field fluid couplings, variable field, variable speed drives, clutches, brakes, and all those listed there. And since 4 years, we started production of electric machines, permanent magnets. We employed several electronic and electric engineers, and we started this production exactly to complete the offer that today we are able to make about hybrid transmissions, hybrid systems, and full electric systems. These are our products. They go from turbo couplings to flexible, complicated, variable. It works, yes, variable speed drive up to 4 megawatt. Clutches, brakes, complicated transmissions, putting together our products, and split power drives used as pump drives, transmissions for vehicles, vessels, boats, and our own electronics. The printed circuit board has been designed by Transfluid. Now this presentation is for hybrid, and what we have done, the philosophy behind this project was to make something, putting together what we are able to make, our products, combining our products to make a solution, a hybrid transmission. So everything you see here for the very simple, the smallest we have, or the presentation I'm showing, they are all products, I would say, coming from the shelves. So these are products we're producing since decades with thousands of applications worldwide. I mean, the elastic coupling, the clutch, the split power drive, transmissions, marine gears, and lately, of course, electric machines. So the main features are that we focused on to be strictly standard. So you can use any internal combustion engine having a standard SAE housing and flywheel, and downstream our system you can install either our transmission or any transmission having SAE input, standard input. So we go up to 1,100 kilowatt internal combustion engine, and we can use up to 150 kilowatt electric power coming from our electric machines. So permanent magnets, we will see later, that this was a choice dictated by the very high efficiency of these type of machines. They can be motor or generator. In a fraction of a second, they can switch from one behavior to the other one. This is, we deserve to spend a few seconds about what the technology today is proposing about hybrid. You can understand that there are no other possibilities beside the two big families of series hybrid and parallel hybrid. In a series hybrid, the only way to move in this is more familiar to you, cars. I know that you're all from maritime sector, but car is very familiar to everybody. The only system to drive wheels or your propeller is the electric motor. So the electric motor then can be supplied by electric current, either from a generator that is driven by an internal combustion engine or by battery. But you have only one source of power having two sources of energy conveying in only one motor. And this is called a series hybrid. The parallel hybrid philosophy is to have two well-separated systems to drive wheels or propeller, that is an electric motor and an internal combustion engine, both connected to the driveline, and then disconnect one each other through a device. We use a clutch. There are other devices. We thought that the clutch would be the best. And you have, as you can see, you have two well-separated source of energy, the fuel and the battery. So you really have two redundant systems to drive wheels or propeller in a parallel hybrid solution. Okay, the serial parallel, it is called this way because, and this is actually what partially we make by using a motor and generator together. It's a permanent magnet electric machine. In this way, if you use generator to recharge, to supply battery, you open here and you work as a series hybrid. So it's a series parallel hybrid, but it's much more expensive. So here we go to explain how our system has been combined and designed. This is the smallest solution we have for marine propulsion, and this is what we call HTM 700. It is made by an input part that is an SA standard, particularly this is SA 4 10-inch flywheel, according to these rules. And we can have an elastic coupling when we use for the so-called Borg-Warner engine output. Then we have a clutch, that is the disconnecting device that allows to switch off the internal combustion engine. And the split power drive, particularly this system can be turned around the clock to find the best location for the electric machine. Then the electric machine, motor, generator, as I said, valve, because our clutch, it's a dry clutch, hydraulically operated. This is a clutch. We go up to more than 1,000 kilowatt. We sell since more than 20 years. We already have more than 10,000 clutches of this type around the world operating. And the solenoid valve to drive oil into the clutch, and the system is completed by our own marine gear. So we source the oil pressure built in the marine gear, so we do not need you bring any oil, just bring a few wires for the voltage to control the marine gear. And so everything is embedded in a single mechanical, hydraulic and electric solution. This internal combustion engine, and we can install here up to 35 kilowatt electric machine, means more than 45 horsepower, so it's not that bad. Now, it would be too simple to supply just a mechanical solution. So the most scaring thing for customers we faced lately is how to make a complete hybrid system, because nobody knows exactly what is needed to make a hybrid system. Battery, inverter, DC-DC converter, electronics, throttle lever, etc., etc. So today Transfluid is proud to say that can supply a plug-and-play system exactly as you bought an engine, an internal combustion engine. The engine, marine engine, is made by an industrial engine plus many things like a cooler, special coolers and other things. So you don't buy an industrial engine and then you complete it with a cooler or other things. You buy an engine, a marine engine. So the philosophy is to propose you to buy a hybrid system. You buy the engine, you buy the hybrid system, you buy your prop shaft and your propeller. That's it. We take care of everything, and our scope of supply that is made, this is the system I showed you before. Our production, this is our product, this is an emergency. Come home to engage the clutch in case of failure of the system. This is our electronic, okay, our product. This is a proprietary software. Display, of course, we do not produce display, but I will show you display. A DC-DC converter we supply inside an electric box. The control leader, this is a bespoke product made by an American company to accomplish our requirements. I will show you how it works. This is a UK-based company making inverter, very good product, and this is completely embedded in our system. Batteries with BMS. Later I show you what kind of chemistry we use. And everything is inside a CAN bus network, and we provide either CAN bus wires and connectors. Okay, this is very important. We use Telemechanique, Schneider Electric wires. So we supply the complete system. Okay, you just need to have a look of our electric schemes and connect marked wires one each other according to the installation manual. Of course, we developed our own software. The software was the major challenge to make a good hybrid system. Today we can say that we have a very reliable software. For instance, we developed the possibility to shift between electric and diesel and back diesel to electric while you are sailing. Any position of the throttle lever, you can switch on the throttle lever between electric and diesel, and automatically it works. It's not a Prius, so the skipper, the captain must decide what to do, if he likes to go diesel or electric or booster or with regeneration, because a vessel, as you know better than me, can face a difficult situation like rough sea, wind, or during mooring maneuvering. It's not how do you say? It's better that that the system doesn't decide to take power from the main power source you have exactly in that moment. This is the display. We have several pages. This is the home page where you can have the state of charge of the battery, percent. You have the range, hours and minutes, calculated by a simple algorithm. When you are in diesel mode, you have the power path showed by these arrows coming from the diesel engine. And here you have the pressure to the master clutch. That is this one. When you go electric, you have the amps. For instance, this is electric, so the power path comes from the electric motor, and minus means we are sucking energy from the battery, and you have always the gearbox temperature. Here in this page, blinking with also the split power drive temperature, oil temperature. Then you go booster mode, so both you have powers coming from the electric motor and diesel engine, and you have amps. And when you are regeneration, this is plus, so you're giving current to the battery, and you're giving power to the generator whilst you're driving propeller. And these are the other available pages. And okay, here you have another page. You can stay this page or home page. You have everything you need. Here, if you are forward, reverse, neutral, if you have a PTO working on our split power drive, the throttle percent you're using, temperature, this is the module temperature, oil temperature, and the marine gear temperature, etc. And here then we have this is selected directly onto the display. So the MPCB page we call, this is the electric page. You have information about electric machine and the frequency drive. We have the battery page, and warning and alarm page with different colors. When it happens, this blinks, yellow or red, and then you press this button and you see which is the alarm you have. The lever, this is a very good thing we have done with our supplier, and everything is on the lever. So we have this is a traditional. This is a traditional lever. Then you have 4 different things. This is the electric button, the diesel button. You just press this or press this to shift from one mode to the other one. And then we have booster, putting together power from electric motor and diesel engine. You keep pressed and the booster works. You release, the booster stops. And this is regeneration. This is a switch, so you just press once and you regenerate, and then you press again to stop it. Booster is a high consumption of energy, so this is why you got to keep pressed. It's used for planning boats to go on the redone, to go planning, and then you release it, or for difficult maneuvering, you can use the booster. When you don't need anymore, you can release. And okay, this is the module. So as I said in the beginning, we can provide our system for any diesel engine, any internal combustion engine, and any transmission. So that is particularly made with that sample with the twin disc marine gear, for instance, the green one. And so not necessarily we want to sell our marine gear. Of course, our marine gear is less expensive. That's not bad. And we provide a full integration drawings for 3D, 2D drawings, providing you give us the diesel engine, or we ask the diesel engine manufacturer to provide a 3D drawing. So we give you a 3D so you can better install inside your engine room. The range. So as I said, and I would say that we are the only one company in the world proposing a range of hybrid transmissions. So we have the smallest one, and then we had other three. The biggest one is up to the 1,100 kilowatt internal combustion engine I mentioned, and we can install, since the clutch is from our production, the split power drive is from our pump drives production, and we have heads with standard SAE B and C pads, PTOs, both sides. So we can install up to 2 electric machines. So on all of these 3 modules, we can go up to 150 kilowatt electric range. We can make adapters. Recently, we made an application with the biggest one. Instead of these needed SA 114-inch, we made it, no problem. So we have available pads here, PTOs, so you can install hydraulics or further generators, small, for hotels, for vessel services, hydraulics, I say again, whatever you need. As I said, we can install, we have already done application with twin disc marine gear, with ZF marine gear, with our marine gear, no problem. We are not reluctant to use transmission from our competitors, or at least customers can buy, you can buy the diesel engine, you can buy transmission, then put together. You put together, but we tell you how, and we are able to control transmission if we have permission from the manufacturer, or our software can be, let me say, limited to our system, and we do not control, beside of course forward, reverse, we do not control transmission. Usually we do that because we have the permission from manufacturer. The same system can be easily used for water jet and stern drives. We already done this application. Azimuth propeller, no problem. We just provide, if you need a cardan shaft with an elastic coupling here, or with stern drive there are a different type of connection, but there's no nothing against our system is used with different propulsion system than a propeller, just a traditional propeller. And okay, we provide all drawings you need. The most important is to understand that the space occupied by our system between the internal combustion engine and traditional transmission is so small that our system is able to retrofit almost every boat and vessel you have. So it's a system that can be easily used for new design or existing vessels. Just as an example, that is only 300 millimeters, 12-inch. The room that you need between the internal combustion engine SAE housing and maybe the marine gear you already have on your boat. And you can use it up to 165 kilowatt internal combustion engine. And the biggest one, it's some 800 millimeters. So this is for a 1,100 kilowatt application. It's not that big. 80 millimeters you need to move either the engine or existing system for transmission. This is to show you that since we use our standard split power drives, instead to install the electro machines here, you can install here, because our split power drives, they can install 1, 2, 3, or 4 heads, depending on what you need. And this is what we propose about electric power onto our modules. On the smallest one, we can install up to 35 kilowatt, and from 8 to 20 kilowatt, we use 96 volt battery, and from 35, the 50, and the 75, we use 288 volt battery. So we have a wide variety of combination. This is a peculiar thing of our system. 2 of 20 kilowatt and 96 volt, the system, I'm talking about the system, it appears to be less expensive than 135 kilowatt 288. So you can easily choose the voltage you want to have on board your vessel. If you prefer to have a higher voltage, means lower current, smaller wires, you can use this, or you can use 2 of 20 kilowatt. That is slightly less expensive. So combination 2 of 50, 2 of 75, etc., etc. We go from 8 kilowatt, our electric machine, all 3,000 RPM, from 8 kilowatt to 75 kilowatt. This is why we have chosen the design for 3,000 RPM. And 3,000 RPM is good for the diesel engine that nowadays they go for higher speed. So the most of diesel engine we faced are between the 2,000 and even 4,000 RPM for pleasure crafts. So 3,000 is well in the middle. And so we do not need to install any specific reduction gear from the electric machine to the driveline. This is the typical torque curve of a permanent magnet electric motor. And this is why it is widely used for hybrid cars, and generally speaking is widely used for the most of hybrid system, because you can get twice as the nominal torque at stall when at still 0 RPM, and you can use this torque. This is the curve S1, the so-called continuous duty. And this is the S2 curve, that is the intermittent duty. We call it intermittent. Evenly spaced, you could use this curve for a 60% of time in a working cycle. We develop our own software to calculate the electric performances related to the installed engine power, diesel engine power and speed, installed electric power, so we can understand if we got to change this power, of course, vessel weight, and and length. No, weight and length. And we give an estimation of the speed of the boat by using the power that we select for the electric motor. So with this program we can check if the selected power is suitable for your boat, and we have all data regarding current from battery to battery, the current provided by generator, the current provided by the electric motor, so we can check everything. This green is continuous duty and blue is intermittent duty. And this is the result. So we match in two different points. This is the propeller curve. This is a logarithmic scale, of course. The propeller curves matches the internal combustion engine, electric motor in the two different modes, continuous and intermittent. Okay. And finally, we can check the booster effect, that is exactly the sum, and it works exactly in this way: the power from the electric motor, the power from the internal combustion engine, the result. Okay? Now, before we talk about the energy storage, that is an important part of our system, though we do not produce batteries, I forgot to tell you that our system is a parallel hybrid system, but you can appreciate that the installation of the electric machine is parallel as well. So we do not make, as some of our competitors they made in the past, the electric machine in line with the axis coming from the diesel engine and going to the prop shaft. Because every time you have a project, you got to make almost a spatial electric machine with a spatial clutch, with a spatial connection. And so this is against our philosophy. We are an industrial company, we produce, and we have a closed loop for economic scale and volumes. So we can easily use all our standard electric machines and we can change power according to the need, because we made a parallel installation by using our split power drives. So it's important to say that we are not selling a dream, and we are not telling you lies. Energy is energy, and if you need energy to move a boat, you got to use that energy. We are not producing energy free of charge for you. But there are many ways to produce this energy in a more efficient way, to use the energy in a more efficient way, and to store the energy in a more efficient way. So actually, with a hybrid, a parallel hybrid, I think, of course, putting together the best of the technology today is offered, we can say that, and we tested on our own boat, because first of all we made our own boat, of course, and you can get a very interesting fuel saving on boat, and we are talking not less than 15%, just because you use better the internal combustion engine. When you recharge the battery, when you go diesel and you recharge battery, you work the diesel engine in a better efficiency area. It means with a better specific consumption. You know what I'm talking about. And this leads to a considerable fuel saving. Even more, you can use what we have done on our boat, a solar panel, for instance, to hold the battery. And, we made our truck also. We have a lorry, you say it's a truck. And we made it full hybrid. We certified in Germany, because in Italy they didn't know what to do when we asked, please certify, give and but now we can drive a highway with our truck. It's a full hybrid, and we developed the CARES for our truck, a kinetic energy recovery system. And just with the CARES, driving a suburban area with the roundabouts and some traffic lights, just slowing down and braking, you can get I remember the first test we made, we recovered in just 10 kilometers of this kind of driving, we recovered more than 10% of the battery charge, just slowing down. Of course, this is more difficult to make on a vessel, but John mentioned, Peter, you mentioned, you mentioned the possibility to use the river stream to move the propeller in some way. Maybe when you're stopping the boat stop, your clipper stops, I don't know how you call it. And for instance, you can keep running propeller, recharging battery, why not? Or you can move a further spatial propeller to take this energy. But these are all systems that, where do they go? They go to the energy storage. And the energy storage, it's very, very important. And it's expensive, of course. But we like to say we do not sell the battery together with our hybrid system. We sell a hybrid system. The battery is only a part of it. It's an important and expensive part, but it's embedded in our system. We cannot provide a hybrid system without the battery, because the CAN bus network talks to the battery, and the battery talks to our system, of course, and this is very important. Why we have chosen the lithium iron phosphate battery? Because nowadays they seem to be the most promising battery for this kind of industry. They are slightly more heavy. They are heavier than the traditional lithium polymer battery, but they have a lifespan much longer than a lithium polymer. We're talking more than 3,000 cycles against 2,000 cycles. And when I say cycle in a battery, is very important, because the lead acid battery, they have the so-called memory effect. So it means when you discharge only partially a battery, it's like a cycle. In a lithium battery, this is also for lithium polymer battery, it's only a partial cycle, it's not a full cycle, okay? So the 3,000 cycles compared to the lead acid battery cycles, they can be even more if we correctly compare the cycle of a lead acid battery, because they do not have the so-called memory effect. So then there's I said the weight is slightly higher, but the cost is lower. So more cycles, lower cost, a little bit heavier. It makes that our choice was, we think, a good choice. So we have chosen this type of battery. Just we made a quick comparison between a traditional battery, a lithium polymer, and this kind of battery. And finally, thanks to the life cycles, okay, the cost per kilowatt hour per cycle wins against the other two, okay? And this was our choice. As I said, it's a slightly more heavy, but nothing against a lead acid battery. It's less than half weight, okay? As I said here, this is the catalog you find in the folder, and has been made by our partner, and they mentioned Transfluid as a partner for this kind of battery. And they are a company in Italy. They make battery. You can recharge in a couple of hours. More than 3,000 cycles. No memory effect. Okay. Very high efficiency. These are batteries. They have a very high efficiency. These are the batteries we use, so we go from typically kilowatt hour is the energy. Inside the battery, we go from 6 to 34 kilowatt hour. Keep in mind, we select especially for boat, we select a battery almost with the same energy of the power of the machine we install. A 20 kilowatt electric machine, we select a 19 kilowatt hour battery. It means since you never use the full 20 kilowatt, never, exactly as you don't use the full diesel engine power in a boat, we experienced on our boat a couple of hours sailing with the same number in kilowatt hour, the same number of kilowatt. Okay, 20 kilowatt hour battery for a 20 kilowatt electric machine installed. And so we go up to 115. These are for 288 volt from 19 to 115, and the 96 volt from 6 to 38. Okay. This is a quite confusing aspect for battery. We have customers, they say, but I have 2000 amps battery, and they refer to lead acid battery. But usually, lead acid battery, they consider the nominal current 5 times more than the so-called 1C discharge capacity for the current. So when you see here continuous discharging amps 100, this should be compared with a 500 amps equivalent energy lead acid battery. Okay, this is must be well understood because we had some confusing from customer. And okay, we developed a software for boats, for marine application, where according to some information regarding boat, like length, number of propellers, displacement, the power installed, diesel power, etc., etc., and according to the electric motor electric motor and generator, the electric machine we install, the energy of the battery, etc., we have 4 different results, and they are the fuel consumption, and that is the fuel saving, of the electric mode. Of course, electric mode, no fuel consumption, but you can sail, this is, you input what mileage you want to sail and how many hours, etc., etc. Of course, the electric mode, if we select a battery that is not enough to sail that mode, here, for instance, the distance 19 kilometers, and you got to sail another 30 kilometers, but you do not have energy. Then you have the diesel mode. If you sail only in diesel, 26 liters, okay, total fuel consumption. Then we have a hybrid mode without generation. It means you sail electric, then you sail diesel, that's it, and you have a 10 liters, you use 10 liters fuel against the 26, or you, sorry, this is a reduction, you use 16 liters, so 10 liters less than diesel only, and then with regeneration, so you sail electric, then you sail diesel regenerating until the energy you store, it's enough to cover the left distance, and then you sail electric, and you can evaluate, you use 13 liters, so you save almost 13 liters of fuel. This is not made just inputting invented data. We use some engine curves of specific consumption according to the load, specific consumption, speed, and efficiency, and we input in this program. So it's an evaluation. It's a comparison between 4 different systems. I cannot swear you will consume exactly 26 liters, maybe 30 or 22, 23, but the comparison between these 4 different sailing modes, it's quite precise. It's quite precise. So we can perform this kind of calculation for you. We provide a full technical specification, usually not the first step when we make our quotation, but next when we perfectly understand what could be the final exact scope of supply. We supply a complete technical specification where you have everything you may need about what is inside our system. We give a 2 years warranty, of course. And finally, some ballpark pricing. This is just to let you go, not with your throat too dry because you didn't understand everything about this system. So this is a simple evaluation of the smallest system, but with 35 kilowatt. So the smallest system with the biggest electric machine you can install on the smallest system. We're around 25,000 euro, including CAN bus wires and connectors. We estimated 10 meters CAN bus wires. And for 1,100 kilowatt diesel engine with a 150 kilowatt electric power, with roughly 30 meters, 195. So finally, we could say that a hybrid system, complete package, would cost between 150 and 180 euro per kilowatt of installed diesel engine, per driveline, of course, okay? Roughly. This is an estimation, but it works. Finally, this is the natural and logic consequence of our hybrid technology. We developed also a full electric drive that is simply our electric motors. In this case, they are motors, and with a standard flange, SA flange, with our marine gear, with battery, same battery of the hybrid, control lever, inverter, a full hybrid system. The big advantage is that since this is an SA housing standard, if you want to retrofit your boat or you want to design a boat that can be either diesel or electric, downstream this flange, whoa, you can design exactly the same boat. And then from here, you can install an electric motor or a diesel engine. And then you install the battery instead of the fuel tank, for instance. But from a design point of view, this is exactly what you are able to make today with a traditional vessel. What else? I think, yes, references. So we made, these are all boats we made, starting from a passenger boat in the north of France, on the River Oise. It's 28 meters long, and it's 45 tons, 100 passengers. And just they wanted to have a bunch of battery banks, and they sail 6-8 hours only in electric. It means the Volvo diesel engine is used as a spare engine, but they like this way. This is a fishing boat. It's an experimental fishing boat made in Italy. It's very, very peculiar. This is the first boat we made. It's a sort of taxi boat. It's 10 people plus 2 crew. It's between a limousine and the taxi boat. The hull can make both services. And this is a passenger boat on the Lake of Lucerne, twin screws. It's a 18 meters passenger boat in Switzerland. This is a very interesting boat in Venice. This is the first of 1,300 boats they have in Venice. This is a transportation boat for goods. Particularly, this is for beverage. And our system provides the PTO to drive the crane. So the crane works either with the diesel engine or with the electric motor. And these are typical for supply. They are the supply vessel for hotels and restaurants in the very early morning, and so they highly appreciated. They can sail in silence, and also to operate with a crane is made in silence. This is Bavaria. That is this is the third manufacturer of pleasure craft in the world, and they designed the first displacement yacht they ever made, and they decided to adopt our hybrid system. So today we made one boat. It's already sailing, and now we're starting to produce in series for them. It's in Germany. This is our boat. This is a picture we taken in Amsterdam last year, where we took our boat for the hybrid and electric exhibition. It's 7 meters, You can test it on the Lake of Maggiore, that is 30 minutes from our factory in Italy. This is in Norway. This is a supply vessel. Interesting application. Mainly it works in the fjords. This is a catamaran. The first two catamarans, they have been made full electric by solar panels, but the third one has been bought by a company, a charter company in Florida, and they wanted to have absolutely a hybrid to be safe enough to go in the ocean, so you have two power sources. And we already delivered. The shipyard is in Turkey, and then it will be carried to Florida, I guess, next spring. And this supply is one of it made us very proud, because Yanmar, directly from Japan, they decided to adopt our hybrid system, and before they show to the world their decision, they have a shipyard, a boat builder, pressure craft, in the south of Japan, and it's a 40 feet. No, it's 38 feet boat, and we already delivered. The system is already in Japan, and they will make all tests on the boat, and then we hope they really officially adopt our system. When they offer a hybrid system with air engine, they use a Transfluid hybrid system. This is the same producer, the same boat builder. He made the first boat, our first boat, the Limousine. Now he got an order for 6 boats for a cruising ship company. They use these for VIP tenders, don't know. And they want to make these 6 boats. We already delivered the first 3 systems, upon 6. This boat is going to Seychelles. The customer, they have the shipyard is in Italy. The customer is in Seychelles. He absolutely wanted a hybrid boat. Yeah, this is a GSE, ground support equipment manufacturer, where we traditionally supply our transmissions, power shifts transmission for vehicles, and they recently bought from us a complete full electric system, battery, electric motor, transmission, everything through MIT. And this is a project for 70 vehicles. We already delivered 9. They are going to Dubai for the next World Expo. This is a UK company. They won the tender for this supply. Thank you. Okay, now, thank you.